5.6 is saying for which values of x will f of x over g of x be less than or equal to 0. So this is quite of a level 4 question which requires a deeper understanding of the inequalities and the graph interpretation. And so here, trying to decipher it, my interpretation was this: at which value or values of x will the y value of f divided by the y value of g be less than or equal to 0? In other words, which x coordinate or coordinates will you take and plug it into both equations and the condition will be satisfied? The condition that we have is the condition that the operation or the quotient of these two functions must be negative or less than, well, they are negative as soon as they are less than 0, but they should also be equal to 0. So that is the condition. So my take on going about answering this question was making sure that I know all of my x-intercepts so that I know exactly what is happening at what point, because these are your critical values in the x coordinates. So making sure that you know them might just help you. And so the x-intercept of f was asked from us from back then. I think it was 5.2. And now if we look at the x-intercepts of g, there's two of them, and the one we already know, it is there by the origin, but the other one that we didn't know was x is equal to 4, and one may have seen it from the graph or perhaps have done it in the way I have done it algebraically, which is making sure and doing the calculations just to be confident and quite convinced with respect to your x-intercepts. And so the next thing is I try to visualize what this would look like in a graph with those critical values. If you would put asymptotes on those critical values, the -3/2, which is -1,5, and the asymptote and the y-axis, which is where your x-intercept is, as well as x is equal to 4. So I divided this graph into 5 sections, and I looked at it and asked myself, what would happen if x is equal to -3/2 or less than that, which is heading towards the negative? What is happening between those two graphs? And what you find is that your graph of x of f is positive from that point onwards. It's equal to 0 in fact at that point, and then it goes towards positive y values as you are going all the way to -infinity. And looking at the graph of g, the graph of g tends to be going towards -infinity as well with respect to its y values as we are heading down towards the negative side of the x values. So what you find there between -3/2 and to -infinity of x values, you would find that it does yield all of that, because if you divide the y value that is positive of f with the y value of g, which is becoming more and more negative, you will always get something that is negative and that is less than 0. And as we are here at -3/2, you will find that the y value of f is 0 and the y value of g is a point somewhere that is negative, so such that if you would divide that y value with that negative value, you will always find a 0. And then the next section is to look at -3/2, which is -1,5, and between that point, the intercept, and the asymptote. What is happening there? What you find there is that the y values of f and the y values of g are both negative, so it will give you something that is positive there, because a negative divided by a negative will give you positive, so it does not yield to the condition. And now looking between -1 and 0, what you find there is that the y values of f are positive there, and the y values of g are negative there. So a positive divided by a negative will always give you a negative. That's something less than 0. But what's more interesting is that at x is equal to 1, you don't have the x value for f. So it's undefined there. So it will put a restriction on that. And as well, for g becomes 0 at 0. Both the x and the y value of g at O or in the origin, you can't really find anything. There's no such a denominator that is 0, and your function becomes undefined. So even there, it's also restricted. So that section there, it's between -1 and 0, excluding -1 and 0. And then going between 0 and 4, you find that f is positive and g is also positive. So f divided by g there, it will always yield something that is positive. But then going beyond the scope of 4, you will find that g is becoming more and more negative, and whilst f is keeping it positive. So there, what you would find is a result that is negative, which will always yield to the condition f of x over g of x is less than or equal to 0. But at 4, g is 0, and g is the denominator there. So if you divide anything by 0, it becomes undefined. So you also have a restriction there with respect to the condition. So your sections are shaded as indicated that you have these 3 sections where x is less than -3/2, and x is in between -1 and 0, and x is greater than 4. And so to answer the question, for which values of x will f of x over g of x be less than 0 or equal to 0, you would have to express this in an inequality form, where you would say x less than or equal to -3/2, and x is greater than 1, and x is less than 0, and x is greater now, last than question 4. 5.7. Use the graphs f and g to determine the number of real roots of 2 over x minus 5 is equal to -1 into x minus 3 all squared minus 5. Give reasons for your answer. Now it gets interesting even here, and so we should look at it. So I would like us to first look at the parameters a, p, and q for both the hyperbola and the parabola. Now if you look at a of the original functions, both the hyperbola and the parabola, there's no changes there, because a of the hyperbola is still 2 and a of the parabola is still -1. But then let's look at the parameter p. Now for the hyperbola it's +1, and for the parabola it's -2. But what happened to it on the new equation, or the now given equation for this question? There's no +1 there on that denominator on the hyperbola. And for the parabola, you have -3 instead of -2. But then the question that you would ask is, what happened to the 1? How do you get rid of 1? By inserting -1. So +1 minus 1, you would get 0 there. Hence, you don't have anything there. But then -2 minus 1, you would get -3. So both sides, the parameter p was shifted 1 unit somewhere. and we know that the parameter p either shifts to the right or to the left. And now if it's being negated, it's shifting to the right, and if it's being added, it's shifted to the left. Although it becomes a little bit complex, or a little bit different here, because the minus means you are going to the right, whilst on the timeline the minus is saying that you are going towards the left. So let's be careful and be mindful of that. Let's look at Q. Now Q is straightforward. On both equations, 4 is Q. And then on both equations, again, on the new one, it's negative. Q is your -5. So what would you need to move from 4? How many units would you move from 4 to -5? So you do your arithmetic real quick and you would guess it's 9. So it's 9 units downwards. You might be wondering, maybe, how does that look for the hyperbole? And here is the graph showing the shift, or the new graph, the comparison between the old and the new graph of f. And so this is what it looks like, and the asymptote has shifted from 4 to -5. And the other asymptote, the vertical one, is now the y-axis. And as well as for the parabola, you can see the difference. Now the x-coordinate of the turning point is +3, and the y-coordinate is -5, as it was attached to the horizontal asymptote. And as the two new graphs, it would look something like this. And to answer the question of having to determine the real roots, now the real roots in essence are where there's an x-intercept, and you can see from this point on the hyperbola that there is only one real root that we have of these two equations where they are actually equal. And I hope you guys learned something today, and hopefully we were able to answer and do justice to these questions and this challenge. And I hope you guys will be consulting me with all the problems that you may encounter, and I will try to the best of my ability to look at them and maybe get a chance to present them and also give you a shout out. So please stay informed and stay studying and focus. Thank you.